Hello everyone. This time I have 9702/11 paper 1 multiple choice question on May June 2022. I tried to solve this question. For paper 1 multiple choice question we have 40 question. So we try to solve one by one. Hopefully we can solve all the question. This number one is which term represent physical quantity. Meter is unit. Then percentage uncertainty, it's not physical quantity. It's about error on the measurement. Quark flavor? No. Spring constant. Yes, that's it. Spring constant is K. And then K equals to force divided extension. So the answer is D. Spring constant. If you still remember, K is force divided X. Yeah. This is Hooke's law. Yeah. Hooke's law. Spring constant. Now, which two are identical when expressed in terms of SI base unit? SI base unit. Joule coulomb minus 1 or kilogram meter 2 ampere minus 1 second minus 2. Oh, I think this one. Wait. When a joule is work, yeah. Kilogram. Let's say joule is kinetic energy. Meter square second minus 2, and then coulomb minus 1. Coulomb minus 1. Oh, wait, coulomb I change into ampere second. So here ampere minus 1 second minus 1 also. So this become kilogram meter square ampere minus 1 and then second minus 3. So not correct, yeah. How about B, joule second? Joule is, let's say, kinetic energy, kilogram meter square second minus 2 second. Oh, this is same thing, yeah. So kilogram meter square second minus 1. I think the answer is this, yeah. But try to see question. Newton meter. Newton is in kilogram meter second minus 2. Yeah, like force m times a meter. So this is equals to kilogram meter 2 second minus 2. So not correct also. And then last one, Newton. This is the value is accurate but not precise, or the value is both precise and accurate. The value is neither precise. The value is precise but not accurate. Accurate but not precise, yeah. This A. Why? If you still remember this is about 9.81, yeah. And then this, it's too much if 2, yeah. This is same thing with 2 over 10, how much percent, yeah, times 100%. So this about 20%. I think this is not precise, yeah. It's not precise. But if 9.81, this is still around 10. So accurate. Yes, that's it. Oh, question 4. Two cables are attached to the bracket and exert force as shown. Okay, we have two force, 15 Newton and 6.00 Newton with angle 20 and 40 degree. Horizontal component N. Horizontal component is this horizontal component for this is 15 cos 20, and also for this this is 6.00 sine 40. With the calculate first. 15. So on horizontal, yeah, horizontal, this is 50 cos 20 plus 6.00 sine 40. It's about, wait, I calculate first. Oh, it's about 18.0. 18.0. Then on the vertical, yeah, on the vertical is, oh, we split here first, this and this. So vertical is 15 sine 20 minus 6 cos 40 degree. I calculate first, yeah. Wait. 15 sine 20 then minus. Oh, this is about 0.534 Newton. Okay, so the answer is C. Yeah, the answer is C. That's it. Okay, we continue question 5. Oh, what is it? Question 5 is the curved line PQR is the velocity time graph for the car starting from rest. Okay. What is the average acceleration of the car over the first 5 seconds? Whoa, 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 whoa. If this is linear, if this is linear, is the gradient of the strike PQ, because the acceleration here, this is acceleration. Acceleration is delta V over delta T. So like this one, yeah. Yes, gradient this, yeah. So not the area, but gradient of strike line PQ. Yeah, this the answer is C. Not the gradient of tangent Q. Yeah, no, because this one. That's it. Then how about question 6? Question 6 is, oh wow, calculation. A ball thrown horizontally with speed of 10 meter second minus 1 above horizontal ground. The ball hits the ground after time 3.0 second. Air resistance is negligible. What is the speed of the ball just before it hits the ground? Okay, this is they have initial velocity. They have initial velocity as this one. This is initial velocity. Oops, sorry. This initial velocity, or U or VO, above horizontal width. After 3 seconds. So we use V square equals to U square plus 2 GH. This 10 square plus 2, we use 9.8 for gravitational, acceleration. And then, oh, we use time, yeah. Sorry. Not use this formula because about time. So we have three kind of, we know, yeah. This is time until ground, and then gravitational acceleration is of 9.81, 9.8 meter second square. Oh, but we use VT VO plus GT, yeah. But this is 10, 9.8 times 3 seconds. Wait, I calculate first. One, and then after 3 seconds hits this ground. So we don't use this. For vertically, they have velocity is 0. Yeah, this is 0, like free fall, 0 meter second minus 1. So when we use V equals to VO plus G times T, yeah, sorry, this is 0, 9.8 times 3. Yeah, just 9.8 times 3. Wait. Oh my god. Wait. 9.8 times 3. 29. No. We have no. Sorry. Wait. I think we use this, yeah. Because they have time until hits the ground, so they have. Wait. Sorry, I repeat again. I check again. What we use here. Wait. Thrown horizontally with speed 10 above horizontal ground, the ball hits ground 3 seconds. Okay. This like this one horizontally, then hits the ground until 3 seconds. I think we need to find wait, find what, yeah. XPO cost, and then they have two velocity. When we find vertically, they have U plus GT. This is 0, 9.8 times 3. This is about 29. This is about 29.5 4 meter second minus 1. This is vertically, and then horizontally we have this, so we root this about 29.4 square plus 10 square, and we root it with times 294 tambah 100, kemudian kita root 31. Yes, 31. Oh, C. The answer is C. Okay, I repeat again if you didn't understand. So we have like vertical velocity, and horizontal velocity. This we have 10.0 meter second minus 1, and then we have for horizontal is 29.4. So because they have like this one, so this is about 31 meter second minus 1. That's it. Question 7 is an object moving along the ground strike line at a constant speed. Which statement about the resultant force acting on the object? An object moving along the strike line constant speed. This constant speed, So when the constant speed, so they don't have any acceleration. This acceleration equals to 0 when constant speed. On the constant speed they have acceleration. So the resultant force acting on the object is equal to weight. Is it? No, it's about horizontal. Ground is horizontal, so I think not depends by weight, not because moving horizontal, we know force is weight is constant, so we have or B, the resultant force acting on the object equal to product with mass and velocity. Oh, no. Why mass and velocity? The resultant force acting on the object equals to resistive force. Equals to resistive. Oh, not the resultant forcing, So a resistive force is include in resultant force. Yeah. Resistive force, this is include of resultant force. Yeah. D, the resultant force acting on the object equals to 0. I think this one. Yeah. This one the correct one. Since A equals to 0, yeah, so for resultant equals 0 also. This is resultant force, yeah, force resultant. Yeah, we don't know, maybe they have resistive force or frictional force, yeah, or from the air. Yeah, that's it. Actually, yeah, the resultant force acting on the object is equals to 0. That's it. Okay, let's check question 8. The water flows out of a pipe and hits wall. It is person. The pipe velocity equals. When the jet of water hits the wall, its horizontal velocity v, yeah, cross-sectional a, the density of water rho. The water does not rebound from the wall. Okay, what the force exerted in the wall by the water? Force exerted on the wall by water. Force is ma. Wait. Velocity. I remember. Here. P is FV. So F is P divided with V. Is it? Power is. Oh, no. Force exerted. But MA. Force equals to MA. Mass we change into rho times volume, and then A we change into v square minus u square divided to distance, let's say 2x. Let's say this is distance is x here. X. row volume is A, yeah, times X. Oh, sorry. A times X. Yeah. And then V square. This is 0 because we don't have initial velocity. Divided to X. Oh, wait. So rho A V square divided to, no answer. Okay, let's say I use Y with unit. We use by dimension. Yeah. Force is, the dimension force is MA. So the unit is in kilogram meter second minus 2. We find this in each option. This is kilogram meter minus 3 meter second. Or use delta momentum mv minus mu divided t, or only mv divided t. What about area? Yeah? Cannot also. Okay. This kilogram meter minus 3 meter 2 meter 2 second minus 2. So this is kilogram meter second minus 2. Is it? Oh, this is force. Yes, this force. Yeah, this is same thing with m times a, right? Oh, I think the answer is wrong. Yes. I just analyze by unit of this. Yeah, unit of this. Yes, the answer is D. Then, question 9. Oh, what is this? A projectile is launched at the angle above horizontal ground and travel through the air. Okay, projectile axiom. The projectile reaches its maximum height at the position X. Some that no upthrust act on the projectile. Which diagram shows the direction of the force or forces acting on the projectile? What yeah? The first one is they have weight. Yeah, they have weight. So when let's say this is projectile on the position X, actually they have weight W. And they don't have any force into something with direction. Yeah, see it's not. And also this one is not. Yeah, when this yes. So when they have this direction, so this is don't have. Yeah, so the answer is B. What about this one? This is air friction and this is W. Yeah, that's it. Question 10. What is a statement of principle momentum? Conservation of momentum. A force is equal to the rate change of momentum of the object. No, this is this is about conservation of momentum. Yeah, this is about force equals to change momentum. It's correct, but not related with conservation of momentum. So this is in the perfectly elastic collision, relative momentum of the object before impact are equal to relative after impact with object before impact. is equal to the relative. Oh no, this about momentum before equals to momentum after. Yeah. In all object. Yeah, in all object. This is not like this is like separation of two object. Yeah. See, the momentum of an object is product mass and object velocity. Yes, correct, but this is about the definition. Yeah, definition. The total momentum of system interacting object remains constant, providing no resultant external force. Yes, this correct. Number 11. A horizontal wooden plank is pivoted at one end. So, okay, the plank has a mass 100 kilogram, the length 10 meter. The center of gravity of the plank is the distance 4 meter from the pivot. What is the moment the weight of the plank is pivot? Okay. What is the moment of weight? Center of gravity is here. Yeah. So this is 100 times gravity. 980 Newton. The center of the plank. Okay, what is moment? Pivot. Yeah, so just we 980 980 times 4. Yeah, this is about 3.92. Yeah, so torque equals to 98 times 4. This is about 300. When mass and object be in equilibrium. In equilibrium is when the resultant force and resultant torque of the objects is equals to 0. When total force equals to 0, and also when total torque equals to 0. So this one. Oops, no, this one. B. So but total force equals to 0 and also resultant torque equals to 0. No resultant force and no torque. Then consists of 1,200 kilogram of oil, density 1,100 kilogram meters the power of -3, and then 1,500 kilogram of oil density 860 kilogram meter -3, and then 4,000 kilogram of oil density 910 kilogram meter -3. What is the density of the mixture? Oh my god, how to solve this? density of mixture is, this density is mass over volume. So this like with mass 1 plus mass 2 plus mass 3 divided total volume, volume 1, volume 2, volume 3. Is it? So mass 1 here is, this is total M. Let's say this is total M, and this is volume. Volume is mass divided rho. Mass 1 divided rho 1, mass 2 divided rho 2, mass 3 divided rho 3. So, oh my god, I calculate first, yeah. Total mass, oh my god, one by one. Total mass is 1 plus 150 plus 4,000. Total mass is 6,700 divided 1 by 1. Mass of 1,000 divided 1. This about 1.09, yeah. And divided 1.74 plus 400 divided, this is about 4.39. Okay, I'll count it. 1.74 plus Okay, what about question 16? A box slides down a rough ramp. Okay. The change in gravitational potential energy of the box is 16 joules. Okay, what was delta potential energy is 16 joule. Let's move between position x and y. The box has 24 of kinetic energy at x. Kinetic energy at x is 24 joules. And kinetic energy also in y is 35 joules. How much work done against the frictional force? Yeah, we just delta kinetic energy, it's like work done by friction is work done by friction like change of potential energy minus change of kinetic energy. So this is 16. Oh my god. 16 minus 35 minus 24. 16 minus 9. 5 joule. Yes. Let's check question 17. The total energy supplied to an electric motor is E. Energy Q is wasted and the remaining energy does usable work. What is efficiency of the motor? Efficiency is this is a total energy supplied. This this E, this is posted here. So useful energy is E minus Q. Is it? Efficiency is useful energy divided the energy input supplied times 100%, or we don't need times 100%. So this equals to divided QE. Is it? Yes. So the answer is C. That's it. Question 18. Objects with different masses are placed on the horizontal surface of a table. The objects are then raised to different heights and height above the table. Okay. The gain in gravitational energy of each object is the same. Which graph best shows the variation of heat of the object above the table? Their mass m. Oh my god. Which one here? Object different masses. The object are then raised different height. The gain gravitational energy of which the gain is same. Which one here? I think this is not correct. Why H is constant, and then this is why H gain up. This is also y up. Yeah. So this one, the answer. Yes, A. Oh, this. Work you have length. Oh, wait. Work you have length. So like Q is half, yeah. LP half, and then diameter Q is twice diameter P. Okay, diameter. K is about force divided extension. Extension where P or extension is force also. Extension force divided K. Something about force. Force P. Oh, we use force itu P A. A, it's about diameter. Oh, I think about elasticity is P divided. Oh, sorry. Stress per strain. Stress per strain. This is stress per strain. So this is something with pressure and delta XL. Wait. So pressure is A delta X divided L. Okay, pressure is in here, but modulus Young. So in this case, yeah, ratio about length is inversely proportional. So like 1 divided a half, and then about diameter is about area. Yeah, this like inversely of L, and then this is directly proportional with diameter square. So with length is inversely, so 1 divided a half times D is 2 times, so 2 but square. Yeah. 1 divided a half is 2, 2 square is 4. So 2 times 4 equals to 8. So the ratio is 8 divided 1. Yeah. This relates about Hooke's law and also elasticity. Elasticity we look about length. Yeah, about length. Pressure relate to the length is inversely proportional, and area directly proportional with diameter square. I'd say maybe one more number, yeah, because so sleepy. Which statement about elastic and plastic deformation must be correct? Elastic deformation, plastic deformation proportional to applied force. No, this is not linear. Elastic deformation, plastic deformation cause no change in volume. No. Elastic deformation causes heating material plastic. No. Elastic deformation reversible, plastic deformation is not. Elastic reversible, yes, but plastic is not. Yes, this is correct. The fixed correct is D. Okay, I think enough first. We will continue with part 2. Don't forget to subscribe. Don't forget to check the part 2. Thank you very much. Bye.